So, hi everyone. This is now going over the notebook that that is kind of following the discussion that I just did over in the initial part of the lecture. So, we are creating the transformer chatbot first pass with a very simple data set, as I was mentioning. So this is kind of an encoder-decoder architecture. It's much more simplified, but because we are using it for chatbots, so this is awesome, great end of sequence. That's really good end of sequence. So this is what we are aiming to have at the end of training, after training a transformer model. Okay, and I'm going to reuse the attention class that I mentioned earlier or in my earlier lectures. So let's go over the notebook. Here we are importing all the libraries that are necessary. Import torch as NN, so neural network, NN.function as F, and all the regular inputs. This is for the optimizer and torch.optim as optim. And then defining your vocabularies. So along with the start at the end token, we have a token size of 6. So ID to token, that is basically mapping all the tokens to the values. Then this is my encoder input, token to ID. What is live AI? Live AI is what? And then this is my decoder input, start awesome, start awesome. So that's the answer that I should be getting if I ask this question. And awesome end, this is the target output. So it has to predict. So after awesome, there could be some other tokens that could have appeared here, but what we did is, because keeping it very simple, it has a start token awesome, but the decoder has to learn that it has to generate till it goes to the end token or till it hits the maximum length that is allowed for this exercise, right, or that is allowed in the model. So max length, right? So this is positional encoding. I discussed in more details in positional encoding. This code is taken from StatQuest. They have a very nice coding, very intuitive positional coding code. So that's what I kind of liked and used it over this example. And then, so I have already discussed about this. I'm just skipping this. Then this is the class attention, and these are the with skew, with query key and value, and then I'm just initializing it with linear d model out features equals to d model, bias false, and then you are calculating the query key and value with similarity score, scale similarity score, then attention percentages as attention scores, and so on. And then we are creating the encoder transformer, simply bringing together. We discussed about this. And then we are also using the, so this is the encoder class, init method, and then followed by the forward method. This is the decoder class with the init method followed by the forward method. So we have the trill that is giving you the mask, right? So you cannot cheat, right? Discussed in more details over there. So mask self-attention values, and then residual connection, cross-attention calculation, then self dot layer normal, and then finally passing to the fully connected layer. This is just to check the values are right. So encoder num token, length of token. So model equals to, so we are just trying to check the encoder model here, the shapes and all. So input is 3, decoder is 2. I'm not using any pack size here at this moment. Then I'm going over to the hyperparameters. So num tokens, d model 2, maximum length is 6, batch size. Well, we are not using batch size, so you can just ignore that batch size. Number of epochs 1000 with learning rate. Then we are going over the transformer class. So bringing the encoder, decoder, the init method, forward method, and this is the generate method that I also discussed, is used for the inferencing, model inferencing. So you keep generating the values till it hit the end. so or end or the number num length equals to 6, right? And you keep appending to the output. So you have a so take the predicted output, the highest value for the largest, and then append it to the generated sequence. And then this is my training loop. So source, target, input, target, output in data loader. So zero gradient, then forward pass, and then trying to compute the loss, then also taking a value of the loss, and we are also printing the loss value at every 100 epochs. And then this is a def or a generate response forward generate response method. So that's the loss, final loss is 0.0057. So not bad. It started with 0.41880 and it ended to 0.0057. So training is complete. Now we'll go over and use the test model to show some results. So now it's generate response, and in both the situations it will actually respond with awesome end. Okay, thanks for listening, and I hope to see you in the next lecture. Bye for now.